we're going to be talking about in Unit 3, Topic 1 is volume, right? And ultimately, like, you may have learned about volume. It's probably actually what you think about when you think about geometry. Before we get too far into volume, we've got to do some review of area, right? Like, you've done area before. I know it's been a while, so we want to take the time to review it so that you're stronger with volume and you're more confident with volume. So I am going to walk you through, or help you, or guide you, I guess I should say, through page 1, right? The finding area and perimeter, so that we get a nice refresher. So the directions are: draw and label each image appropriately. Make it your own. Emphasis on that. Then identify the formula to determine area. Finally, find the area and perimeter of the example you created. So I'm going to go through the formulas and I will do some examples, but just make sure you're not copying mine. Like, make your own, right? Like, you're making almost your own problems to do, which is a great skill to have. So I'm going to start off, and I think I'm going to go down the list, and I want to draw a picture of these, each of these, right? And then we'll talk about the area formulas. So a rectangle, right? Like, we spent some time talking about quadrilaterals. A rectangle, here's my picture. It's not going to be perfect, but it's going to be mine. Here's my rectangle. I want to make it, I don't want it to look like every side is the same. Like, that's a square, which is a special type of rectangle, but I don't want everyone to be aware of what to do if not all of your sides are equal. So a rectangle has 4 right angles. Ooh, those are my right angles. And I am going to say that mine's 10 centimeters by 4 centimeters. All right, so there's going to be my rectangle, and I'll come back. You know what? I'll do the area formula. So the area of a rectangle is length times width. So I'm multiplying the 2 dimensions. It is important to know that length and width must be what's right here. They must form a right angle, which means that they must be perpendicular. Right? And that's always true whenever we're talking about a length and a width, or a base and a height. Base and height have to be perpendicular. You measure height perpendicularly from the ground, or perpendicular from the base. I'm also going to make a note up here that area is always units, whatever your units may be, squared. Whereas distance is just the length. Okay? So there's my rectangle. I'll come back to finding the area a little bit later. Parallelogram. A rectangle is an example. It's a special case of a parallelogram, but I want to draw one that's evidently not a rectangle. Like, I don't want it to have 4 right angles. Let's challenge ourselves. So here is my parallelogram. Clearly not 4 right angles. Opposite sides are parallel. Opposite sides are congruent, just like a rectangle. And I will say mine is going to be 5 inches and 6 inches. The area for this is also length times width. I'm also going to make a note again that L and W, or length and width, must be perpendicular. So I would need to give you a little bit more information, or you would need to actually find the width here. This is not the length and the width. I cannot just simply multiply those together where I can up here. Okay, so let's keep moving. We'll go back to finding that in a few minutes. I just want to get through the formulas with you all. So the right triangle. Okay, so a right triangle means that I have 1 right angle. You guys have done so much with right triangles, right? Through right triangle trig, Pythagorean theorem, the equation of a circle, all of right triangles keep coming up here. So this is me, my right triangle. And you know what? I'll make it a challenging one. Let's say this was 5 and this was 13. So a right triangle is kind of like part of a rectangle. To find it, I'm going to say base times height divided by 2. Or some people will say 1/2 base times height. Right? Once again, base and height, B and H, must be perpendicular. I cannot just multiply. So I can't multiply 13 times 5. I would need to go about finding my third side, which in my case I would need the Pythagorean theorem, right? So it didn't say that I had to do it like this, but I figured I might as well practice more skills in this. A trapezoid. Trapezoid has, it's almost like a triangle with the top cut off, right? We've done stuff with trapezoids because you guys spent time with quadrilaterals, right? You did that whole Flipgrid quiz. I'm going to draw my trapezoid in a way that maybe we don't. I don't want to draw an isosceles one. I'm going to make this my trapezoid. It has one pair of opposite sides parallel. And you know what? I'm going to say that this is a right angle because that's actually going to make my life a little bit easier. So I actually have two bases. Let's say this one's 12. Oh, I didn't add units in here. I'll say feet and feet. And meters, I'll say this is 5 meters. And I'll say this is 2 meters. To find the area of a trapezoid, I'm going to add the two bases, divide by 2, times the height. So it's almost like you're averaging the bases times the height. There's a lot of connections between these. Once again, height must be perpendicular to the bases. So that's kind of why I made this a right angle. I figured that would make my life a little easier. Okay, this is a little blurry, isn't it? Wonder what that does. Oh, yeah, that helped. Oh, awesome, neat. Okay, 2 more, and then we'll go back. So circle. I'm gonna draw a circle. Oh, we spent so much time with circles. 2 important parts of a circle I hope we know at this point are the center and the radius. You know what? I am going to give you the whole length of the cross, which is the diameter. So let's say the diameter of my circle was, I don't know, 18, I want a new one, millimeters. This is a good one. So area is pi times the radius squared. Nothing to do with perpendicular here, right? Don't worry, we're not going to find the area of an ellipse or any of that stuff. Just a circle. So a circle is pi r squared. I'm actually curious if you guys know how to find the perimeter or what the actual word is. Perimeter for a circle has a special name. It's circumference. Circumference. And in this case, you would do 2 pi r, which is just, well, 2r. 2 of the radii is just the diameter, so it's 2 times diameter. So here we have some basic ones. I feel like you guys have been exposed to some of these in the past, and then this one might be a little different. A non-right triangle, meaning we don't have a perpendicular base and height. So I'm going to just draw a nice triangle. Remember when we did non-right triangle trig, we had the law of sines and the law of cosines? Good times. So let's say to do this, I know 2 sides of the angle between them. That's what I know. So let's say it is, what have I not used? Let's say this is 6. I'll just say inches, and this is 9 inches. And let's say this is evidently not a 90-degree angle. Let's say it is 72 degrees. So we have this formula, which is actually on your formula sheet. We should look at our formula sheet and see which ones of these do come up. Like, which ones do we need to know by heart? So area equals 1/2 AB sine C. So it's actually really similar to the equation of a right triangle. But if you recall, if that angle between them is 90 degrees, the sine of C goes away. So it just ends up being 1/2 AB, which is really just a right triangle. So if you use this for a right triangle, that's totally acceptable. Okay, so this is kind of where we are with this. Let's see if I'm going to go back and see what I can fill in. If not, like, you create your examples and you can do it from here, right? I can now say that the area is 4 times 10, which is 40 centimeters squared. Show your work. I'm going to emphasize that. Show your work. Perimeter is the distance around. I don't care about a formula. It's going to be 4 plus 4 plus 10 plus 10. So that is 4, 8, 28, and it's just centimeters, right? And as I was trying to emphasize when I got cut off, show your work. Show it. Like, my work is perfect. I hope yours is too. Okay, so my issue with my parallelogram is that I don't have the height. So in some cases, you might be using the Pythagorean theorem. In some cases, you might be given it. So let's say you were given it, right? So I was given this, and I was told that that is, I don't know, 4 inches. The 6 is irrelevant to my area. It's helpful with my perimeter, but it's irrelevant for my area because we know that length and width must be perpendicular. So you've got area equals 5 times 4. So the area of this is 20, and don't forget, inches squared. For the perimeter, I need that 6. The 4 is actually irrelevant. So I'm going to go 5, 6, 5, 6. So, I wrote the wrong letter up here, guys. So your perimeter is going to be 5 plus 6 plus 5 plus 6. Yes, you can do 2 times 5 plus 2 times 6. That is totally acceptable. 10 and 12 gives you 22 inches. So inches squared versus just inches. Okay, my right triangle. Remember, I made this one a little bit more difficult. So base times height divided by 2. I don't have it. So let me do Pythagorean theorem first. I've got a squared plus 5 squared equals 13 squared. A squared plus 25 equals 169. So a squared equals, if I subtract 25, 144. So that a is 12. So this height is 12 feet. So 13 is not going to help me with my area. Right, so I'm going to have 12 times 5, because those are the ones that are perpendicular. They create my right angle. Divide it by 2. I believe that's 60 divided by 2, which gives me 30, and we're not going to forget it, feet squared. Perimeter, look, I got my 3 lengths. So we would have had to do Pythagorean theorem no matter what. So I do challenge some of you guys to maybe give different measures, right? Like, don't make all of your triangles look like this. Give yourself a different type of problem, right? We do 12 plus 5 plus 13. 17, 20, I believe that is 30 feet. Ooh, we're almost done, guys. Okay. The trapezoid. Oh, this is going to be tough. Oh, no, it's actually going to be really good. I love this problem. Okay. So base 1, 12 plus 5 plus base 2 divided by 2 times 2. Right? I could have said 5 plus 12. You can add in either direction. It's the same thing. So this gives you 17 divided by 2 times 2, which ends up actually just giving you 17. So my area is going to be 17 meters squared. I'm going to do this really quick. Okay. For the perimeter, if you notice, I'm missing this length. So I'm going to have to do a little bit more. So if I think about it like a right triangle, I actually can figure out this little length right in here. Right? This whole thing is 12. From here to here is 5. I'm getting that from up here. It's parallel, sorry. This whole thing is 12. From here to here is 5. So this part has to be 7. So I can actually do the Pythagorean theorem to find this length. So I've got this little, I'll redraw it over here. It's a little right triangle with 7 and 2. So you can see that right there. So you've got 2 squared plus 7 squared equals to c squared. 4 plus 49 equals c squared. So that is 53 equals c squared. So c is going to be the square root of 53. Let's just leave it. I don't need a decimal. I mean, I guess we can, but I don't have my calculator with me right now, and all I know is that's between 7 and 8, so let's just leave it. And we're going to add the sine length. So I'm going to add 2, 12, the square root of 53, and 5. So 2 plus 12 plus the square root of 53 plus 5. I can combine the 2, 12, and 5. I can't combine it with the root 53, unfortunately, but that's okay. 14 and 5 gives us 19, so it's just 19 plus root 53. meters. If you have a calculator and you want to get the decimal, that's fine. I'll be okay with that, but hey, this is showing you can do everything without a calculator. Good to know. Okay, so now we've got this circle. So 2 more. Circle, pi r squared, my favorite. Area is pi, be careful here, it's not 18, it's going to be half of that, so 9 squared. So the area is just going to be 81 pi millimeters squared. And you can speak more directly with your teacher about this, but my preference is to leave the pi. Leave the pi. Unless you're comparing two things, like something that's a circle and something that's not a circle, just leave the pi. Right? Like I was able to do that a lot more simpler. Oh, I did it in the wrong place, but that's okay. So this should have gone over here. It's just gonna, I mean, pi is an irrational number. It goes on forever and ever and can never be expressed as a ratio of 2 integers. So I just leave it. It's a lot, it's gonna be a lot less of a headache. So, that's wrong. That should say pi times diameter. My fault. When I'm doing this, same idea, right? So I've got 2 pi r, 2 times diameter, so it's just going to be 18 pi millimeters. Millimeters, right? It's not, oh man, it should say circumference. I'm on a roll right now. Circumference, which is a circle's perimeter, right? The length around, this circular part around. Okay, and then the last one here. So 1/2 AB sine C. Area equals 1/2 9 times 6 times the sine of 72. So area equals 9 times 6 is 54. Half of 54. You know what? I'll write that. Half of 54 is 27? 27 sine of 72. That's ironic. Inches squared. You know what? Where's my calculator? Oh, there it is. So let's say I wanted to put this into my calculator. I guess this is pretty important. Let's not forget that we have to be in the correct mode. So I'm going to click mode, whoops. And oh look, mine's already there. If you've ever cleared your calculator, it's going to default to radians. So you're going to want to make sure it's in degrees because we're talking about 72 degrees. So 27 sine of 72, which is, if you wanted to approximate it, right, that's approximately 25.679 inches squared. Right, I like to round to 3 decimal places, so 5 and above round up. Awesome. Oh, I did it in the wrong place again. If it is a non-right triangle, I'm going to say don't worry about this. I'd be happy to show you how to do it, but I know I don't want to put too much on you all at once. So you would have to we'd have to find this third side, and to find it, we'd have to use law of sines, law of cosines. You would actually have to use law of cosines because we don't have any full pairs, if you remember. Many of you guys were very strong with that. So if that's something that interests you, if you're trying to find all the connections between everything, go for it. Like, more power to you. That's awesome if you know how to do that. This is where we are with it. Keep in mind this. So this is. I'll give you a full my full paper. Oh, is that my full paper? My full paper. I guess I will circle these. Make sure like you're using these as examples, but come up with different examples. Maybe you'll have some like what if scenarios, but have fun.